Hi everyone. For today's lesson, we are going to extend the idea of electronic effects to explain the acidity of certain weak acids or organic acids. Alright, so these are the steps behind it. The first step that you should take is to draw the structure of the conjugate base. Right, so if you can see, we have three different things here. Alright, we have an alcohol, we have a phenol, and we have a carboxylic acid. Okay, so the first step is to draw the conjugate base, and I have already drawn it here. Right, so I remove the proton, and now I have alkoxide, phenoxide, and a carboxylate. Okay, so the second step is for us to see whether the negative charge is dispersed or intensified. Basically, we are looking at the stability of the conjugate base. So if we have electron withdrawing groups, it will intensify the negative charge. Sorry, if we have electron donating groups, we will intensify the negative charge. If we have electron withdrawing groups, we will disperse the negative charge. Alright, so let's take a look at our different conjugate base. So in the first example, you can see that this blue highlighted portion, right, is an alkyl group, so it's electron donating. In the second example, we know that the negative charge can be delocalized via resonance. The third example, we also know that it can delocalize via resonance, but because the oxygen atom is more electronegative compared to the carbon atoms, right, the electron density in a phenoxide lies nearer to the oxygen atom rather than the ring. On the other hand, because both of these oxygen atoms are equally have the same electronegativity value, so the electron density is spread well between the both of them, so it's equally spread out, so it's more dispersed. All right, so in that case, okay, we know that the conjugate base of the alcohol is the least stable, right, least stable, and then the conjugate base of the carboxylic acid is the most stable. That is why it will stay that way and will not move in the reverse direct. The position of equilibrium will lie towards the right, and so it's more acidic. So how do I represent this in an equilibrium equation? All right, so this is our expression for an acid. It dissociates to form H plus and A minus. So this is the conjugate base here. The more stable it is, the more the position of equilibrium will lie towards the right, and this gives you a higher concentration of H plus. And because you have a higher concentration of H plus, this becomes more acidic. And so this is how we can explain acidity using electron withdrawing groups and electron donating groups via inductive effect, resonance, or delocalization.